Hello guys and welcome to my channel. So today we'll try to I'll teach you how you could actually build a wrapper more or less around the Python package. So the point would be for us to actually write some modules in Rust and then cross compile this of course to Python, or more or less have the possibility to invoke this function, the model that this will create from Python. And I'm just going to keep this tutorial as simple as possible. I'll again try to, of course, cover the very basics and share every possible documentation you might need to get started. And then we see how we can proceed from there. If, of course, someone comes back later and says that they would want us to delve deeper into a certain aspect of this, then we can definitely do that. So let's really jump right in. Let me see where I am. So I can now see it to my desktop, and maybe here I can create a directory and I can call this matrix. So I will try to create a library in Rust that we can actually use to do some compute intensive um, iteration or whatever in Rust, and then we can then of course cross compile this to Python. So one key thing you can always look out for is that so when there is a when it is of course in question to let's say talk about how you can optimize some performance critical loops, for example, or maybe you would want to utilize some custom data structures that are in Rust that are not available in Python, or most maybe some complex algorithms, some intense IO operations, whatever it might be, some syscalls. These are some of the scenarios whereby we might want to actually do the implementation in Rust and then have this, of course, as a binder to Python, and then we can cross-compile this and then invoke these functions from Python. And it doesn't, of course, have to be just Python. It can also be like full-blown modules, could be classes. The whole thing we can actually do in most of the things actually that we can do in Rust, we can already do this in Python. So I'm just going to go ahead and create this directory called matrix move, and then I'll open this in the code editor. So I'm going to use VS Code. So and I open my current. Okay, I should do something like this matrix, and then this of course should open the directory for me. I'll open that in a different window, but here it is. So I will zoom out a little bit so we can actually have some more room to work. So what's how we can proceed is actually quite straightforward. I'm already assuming you have Python installed. You should already have Rust installed. And you should also have Venv for creating and managing virtual environments installed. So and the Python I'm running, I can also show you, is version 3.12. So I'm actually just first thing I would like to do is just to go ahead and create a virtual environment. So I can simply Python m venv, and I'm simply going to call it venv as well. And this should create a venv folder for me here, as you can see. And when I have this created, I can now, of course, activate this virtual environment. I'm on Windows, so I can say source venv, and I go to scripts, and then I run the activate command. And now this should activate the virtual environment for me. If you look over here, of course, you see the same name that we have here. So this name can actually be anything you want it to be. It doesn't necessarily have to be this venv, can give it any name you would want to. And of course, now that I'm inside the virtual environment, the first thing I would really want to do in here would be to install the Marturing package. So this is actually what we'll use to bootstrap our application. So I'm simply just going to go ahead and do pip3 install and Marturing. And this will go ahead and install the package for me. It shouldn't take long. So this is installed. I already installed it before, so that's why it's also taking it from the cache. And now I can just go ahead and say Marturing init. I think I spelled that wrongly. Init. I would like to use Pyo3. I would tell you a little bit about these other bindings. Of course, actually, that's a really cool link here that you can always look through to. So what I'm gonna do is maybe I'll come over here and create a README file, and here I can maybe add a subsection here. I can call this bindings, and then I would just dump this URL here. I'll format this, of course, in the end before I commit this, so you would have access to it. So, but anyways, I'm going to go with Pyo3, and that's actually all we need. So now if I expand here, I will actually see this created for us. So of course, this the main file that this uses under the hood, of course, is this Pyo3 package. So it's quite simple and straightforward function. And if you can, from what you can also see here, we have like a single function called sum as string. And now, of course, this name would take the exact name that our package has, because if we look into cargo.toml, this will of course be the name of our package. And that's also the name we would see over there. And if we also look here, pyprojects.toml, this should also be the name here. If this name and the one here, because the one here would of course be like the root model, if they do not match, we would have problem invoking this function. We would actually not be able to find this function when we do. Okay, so that's like a very simple function. It expects a lone function called summer string. It takes two arguments, two u size a and b, could be 3 and 5, whatever, and then we can simply invoke this function to see actually what happens in the end. So to test this out, I'm going to create a new file here. So this is actually how I would be able to test everything. I call this main.py. And then, but before I, of course, export this binding more or less, I still need to use the Material, of course, package that we installed earlier, and now I can simply call this develop option, and this should be able to compile and of course export the binding for us. And when this is done, what we will now do would of course be to try to use this from our Python environment. So I'm going to give that a couple of seconds to install, and then we can continue. Okay, now the installation is done, and maybe next now what I want to do, of course, would be to select the correct interpreter, and I'm going to select the one from the virtual environment. So after this exports, again, one thing we can actually do, like you would, for example, if you're working in like, let's say, a Python project, I can come here and create a requirements .txt file, and here now I can actually add this package. So when we have this let's say published to the public repository like PyPy, for example, we can easily have this in here. And now in our Python package, I can now come here and do some like Python install add for read. I would like to read the requirements txt, and then this should now install this for us. And we seem to have some issue here, so let me try to fix this. So I can say python, oh sorry, this should be pip3 install, and then I read this file, and then if I try to install this, of course it will now tell me that this is already installed. But now I can come into our main py file and then try to use this. So I can simply say import matrix mul like this, and now I can simply print this. I can call this package, and the function was called this, so summer string. I'm also going to call that exactly that in here, and then I pass two arguments. I can say 5 and 6, for example, and then I run the Python function. I can also Python main.py, and you can see out here we get an output of 11. And this, of course, what we can also do is to type this return statement. So I'm going to maybe cut this here and say results is equal to this. And now I can print results, and maybe also the type of result. So we actually see if the type is consistent. So this should be result. Okay, and then we call the function again, and then you see here, of course, the return type is string, which is really what we expect to happen here. So that's like a really basic working example of what we'll be doing today. So what we'll go further to do now is to show you how you can go beyond defining functions, but of course, like define classes, define enums, and use some custom data types in Rust, and to of course develop this, and then in the end still use our binding and try to invoke the same function from Python. And maybe if we have time, I can also show you how we can actually invoke Python from within Rust. There's really so much we can actually cover here, but what I'll try to do next now would be to list more or less a table of content regarding what some of the points we would like to cover today, and then we'll try to follow them accordingly. So I'm just going to come over here and make a short list about what we would be covering in this tutorial. So I can maybe come here and say content. If I can spell today, So under content, I'm probably just going to group this under a couple of topics. So I would have functions. And so with functions, I'll try to cover like different ways of passing arguments and of course default arguments and all that. More or less try to cover everything that you would of course might need when you're trying to define functions. So in here also we'll talk about handling, raising and handling errors. And of course, maybe custom errors as well when we have the time. And then other than functions, I would like us to again look at enums. So look at the possible ways we can actually define enums and maybe classes. So under classes, I would like us to cover like basic things about classes. Maybe we can cover inheritance if we have time. And let me see what else we can actually cover. And of course, we would cover constructors. So we can have here constructors. And we can also cover maybe objects properties. And so when we have the time, these are some of the things I would really like us to cover. This would more or less, I think, form the basics when it comes to getting started with working with on a project as this. And if for any reason there is a need for us to go deeper, we would definitely go deeper, of course. So let's really jump right in without wasting so much time. I'm just going to jump over to our main file here, librs, and then we can start making modifications accordingly. So the first things that we would need to know is this. So the function here, um, like I said initially, should always have the same name as like our module, and also exactly what we have in here, because this would define the the module we are trying to develop in Rust. The name has to match what we have here, and this will of course function as our base module. So this should again be exactly the same as what we have in Kagotomo. Otherwise, Python will not be able to import this module. So from this simple example over here, you've already seen how we can already declare a function and add this to the base module. And we also again have the option of actually adding submodules to this main module. And that's also quite pretty straightforward to do. I can show you a simple example by maybe coming down here and defining a new function. So I've added the py function trait. And under it, I can define a function and I can maybe call this func1. Func1 should not do anything for us now. It might only, let's say, return a string. And inside here, I can do some like string that's from, and I can say hello world. So now I have a new function called func1 that simply, or maybe I give it a descriptive name. Descriptive name. I can call this hello world actually. So that should be the name. So when we invoke this function, we should get back this string hello world. And so now we have the option, of course, to come in here again and add this function to this module. But if we wanted this module to, of course, live in a completely different sub module of this main module, it's also pretty straightforward. What I can do is maybe come down here and define a new function that we would use to register is a child model. And I can call this maybe register child. It has to have the signature, it should take a parent. And the definition, of course, should always satisfy this lifetime parameters that we're setting here. So it should be one of these, and of course, py module. The return type would be py result. Py result. And for now, it's not going to return anything. So inside this function, this is actually where we can now define a new submodule and then append this, of course, to our base module. So in here, I can call this child. And this child will use this py module module more or less from Rust. I'll say a new bound. So in here, I now need to, of course, define the parent. So parents would come from this. I can say parent.py. And now I need to provide a string that would define the name of this submodule. I can call it module B, for example. and we of course handle our error this way. So we have our child, and now what we can simply do is I can now say child.add function, and now I can actually again do exactly what we did up here. So I'll call this wrap function macro, and to this wrap function now I can now provide the function that we defined below, which was called hello world. And after that, of course, I need to provide the child, a reference to the child. I'll handle the error from here and here as well. And at this point now I can return, of course, the submodule. So I can simply say parent.add submodule. And now I simply pass a reference to child. And now all I need to do is now come up here and call the function. So I can say register child. And in here, I simply pass M. Of course, M would be our module. I need to close this one up. And of course, this should be able to add our module. And this, of course, returns an error. So I can also handle it this way. So what we've done now is to create a submodule within our main matrix mole module. So within it, we have a submodule. And within this submodule, we now have a function called hello world. So to verify, of course, and see if everything is working as expected, again, I'm going to go ahead and call this develop function. And then we'll look into, of course, we'll try to invoke this function from our main.py file to see if everything actually works the way we expect. So now let's go over to our main.py file. So here, this is of course pure Python code. Now I can say matrix mole, and now I go to the module that we created. We called it module B. If I come back here, you can still see the name. I'll probably just copy this, come over here to show you this is the module, and now the function was called hello world. And I save this and then invoke this function. And then down here, of course, you see that we actually get hello world. So this is one simple way we can actually define a submodule and have this invoked this way. So within the main module, we can of course define multiple submodules, just like we could still within Rust. And then we can easily and efficiently group our code into submodules, and then we can of course consume them this way from Python. This is actually the way it should be. So let's continue. So now that we've seen how we can define functions, submodules, and also define functions within those submodules, one thing we can also do, if you look here, we would always have to define our modules this way and then try to append them this way. This might actually be tedious when our code base actually starts growing. So what I might want to do now is to show you how we can also achieve the same thing by defining the module the same way we would say in Rust. Okay, so I'm just gonna come down here and define a model. It's still gonna have the same name as the one we have up there. So I'm still gonna call it matrix mode. And then what I need to do now is to come up here, of course, and add the PyModule annotation trait more or less. So I can say PyModule. And of course, we still have the option. Now this is complaining because I now have duplicate modules having the same name, but that's also totally fine. So what I can do is this module that we have in here, I can actually maybe get rid of this, and just to maybe I can actually just get rid of everything and then we redefine this again. I would like to show you how this could work if you're of course like me coming from Rust. So this way, this would always have the name of the module we define here, but again you also have the option of actually coming up here and passing a name argument, and in here you can actually give it a new name now. So you can give it any name you want. I'm just showing you this, that it's also possible to rename this to whatever it is you would want to rename this. Okay, so maybe what I can now do is to come here like we did before. I'm going to define a new function just to show you how you can define a function within a module, and of course outside the module. So I can call the py function trait, and in here I would like to create what is this? And in here, I would now like to define a function like we did before. Again, I can just like we got from the example, say some as string. It's going to be exactly like we had before. It's going to take a usize and another usize, and it should be able to return a pi result. And within here, what we would want to get back would be a string. And down here, just like before, I'm going to do exactly what we did before. So in here, I would say a plus b, and out here we can now say to string, exactly just like we did before. And now what I would like to do is to come in here to show you how you can actually bring that into what did I do to bring that into this new module we are creating. So in here I can actually say use super to bring in everything including this function, so that I can actually add this function to this module. And now here I can maybe now export this function within this new module that I created by using this annotation pi module export. Add, oh come on. And then in here I can now say use super and sum as string. And now this function, this one we have defined outside of this module, would now be exported within this module. And that's actually the goal. But of course, within this function, within this module, we have the option to define further options, define further functions. So I can create a new function here, and of course, add the annotation, the thread pi function, and I can give it a name. I can call this, say, triple. So this should take a usize and return a usize as well. And in here, it's still just going to do something quite simple. So you simply just multiply or return this, of course, to the power of 3. And now what I can actually do is I can maybe copy this and create a new function down here. And I can maybe call this version, and because I would like to show you a few tricks. So this may not actually take any arguments, but it will return 1. So this could be a function that we would use to return the version of our module, for example. And even within our module now, we can also even create submodules. And again, it's also quite straightforward. I can come in here, create, of course, add the annotation pi module. And then in here, I can define a new module. I can call this maybe sub module, whatever I would want to call this. And of course, that continues infinitely. So we have this sub module now, which is now part of our main module. And we can also maybe even add a function in here and invoke it to see how everything works in the end. But why I added this function here is I would like to show you how we can actually add an init class. So when you are working with Python, for example, I might want to come here and define a class, and I can call this sample, for example. Maybe I have the option of coming in here and define an initial. So this is going to, of course, serve as my constructor. This would be called when this function is initialized. And of course, I'm in Python, not Rust. So we have this option, and in here, for example, I can do something like print and say hello from class sample. And now down here, what we can actually do is I can instantiate this class by saying something like sample is equal to sample, like this. And just initializing this function would, of course, invoke our init function. So to have this same functionality here, what I would like to do would be to define, of course, an init function. So I'm going to have to create a function called init. And of course, giving it a name of init doesn't actually make it an init function. But again, as you might have guessed, we would need to come up here and add a thread, the pi module init thread. So I can say pi module init. And then this function would also have the same the same signature, the one we defined initially. So I'm gonna come over here again and pass my bound. And in here, I'm gonna pass lifetime parameters and pi module. Again, it should return, of course, a pi result. Pi result, and in here for now, it's just gonna return a unit. It's not gonna return anything actually. So in here now, I can now add my modules. So in here now, I can now define, of course, what I need to happen within my init function. So here I can say m.add. So n, of course, being my module itself. And within here, I'll need to specify a name, first of all, and of course, then what should be um, what we can actually now get from this name. So here I can actually call this version. And down here, I would now use my get attribute down here. And of course, I give it a name and I'll call this version. So this name, of course, would now match, of course, the name I have up here. And now I can handle my error this way. So the point would be now that when I initialize this module, this function should actually be triggered for me. So that's really the point. And actually, I can actually, of course, print this out so you can actually see what's going on. So now let's go back to the main file. And now what I can actually do is to come in here, come down here, and now I can actually do something like this. For example, from matrix mode, I can say import version, for example. And now I can now do something like print, and I'll say maybe the module version is, and now I can add that attribute called version. And again, I also have the option now to do something like this. So maybe I copy this again, come down here, and print this as well. So I can maybe get rid of this or comment them out completely so we don't get any confusions. So these are all commented out. And now we can try to, first of all, of course, compile this one more time. So I can say maturing develop, and they should compile our code real quick for us. And after that, we try to invoke the main function to see what we get. So now I can say Python main, and we have some error. Okay, I'm just going to take this out for now so we focus on what we want to see. And now if you look here, of course, we get, did we make this 11? No, this should have been a 1. So yes, of course, this is this one. And we are getting some error here. Of course, this has to be invoked because this is actually a function. It's not just a simple string. So that's also why what we get here is a built-in function. So now if we invoke the function and run this again, we should get that this is 1. So this is of course, giving us the option to more or less initialize a module. But as you can also see, for example, this is a lot cleaner to work. This is also a lot easier to work with than what we had initially. So going forward, this would be exactly how we define our modules. So now I'm going to collapse this part so we have more room to work. And what I might want to do is to come in here and create a bunch of submodules. And I would like to use these to actually group a couple of things within this main module. So in here, I would call this one maybe functions. Maybe I'll get rid of this because I don't know what name to give them for now. So, but in here, I would like us to look at a couple of points that we would need to pay attention to when we're working with function modules. So when we define a function using this syntax, this is us, of course, defining a Python function from a Rust function. So what this implies is that when we define a function like this, that function needs to be added to any module, any given module, using the wrap function macro. Or that's one thing you would have to pay attention to. So, but what we will do now is we will of course go ahead to add a little additional information to the functions that we define. And most of those I will have to define within this function submodule. So in here, we can actually define a function this way. Of course, I'm still going to use this wrapper like this, and oh, sorry, this thread. And now I would like to add another thread because I want to show you how we can maybe change a function name. So I'll use Pyo3, and in here now I can specify a name. And now I can give this function any name I want. I can call this func null. Okay. And then down here, I can of course define the function. And I might call this actually say return null. And this is gonna, again, I'm gonna return usize. So in here, I'm probably just gonna return 0. And don't worry about the errors. All we can simply do is to bring this into scope, for example, and this should take care of this for us. So, but we have this function now defined that we call return null. And but we also have the option of using Pyo3 to rename this function. So when we add this to a module, it will still be referenced within using this return node name. But of course, we want to use this from function from Python. This is the name we would reference it with. So we have the option of actually giving it a new name if we wanted to. That's totally up to us if we want to do it like this. So now to test things out to see if this is actually working, now I would again compile this, smart ring develop, and that shouldn't take so much time. Okay, and now we have that. And now so I can come down here and maybe down here now I can do something like from matrix mode, I say import functions. That was actually the name we gave it down here. As you can see, this is the name of the submodule. And then in here now, I can maybe try to invoke this function. I can say functions, and let's see. So like I told you, the actual name was this. So let's try to invoke it with this name. And so we'll say Python main. And you can see here, we actually get that this module has no attribute called return null, simply because over here we've actually renamed it. But if I can take this name now and come down here and replace this with this and invoke it one more time, now we actually get what we expect. So there's actually one handy way we can have submodules, and within those submodules define functions. And again, I've also seen how we can rename a function to any more user friendly or whatever more compatible depending on the module we're working on, and what could be more understandable for the people working with us in that same package. So that's one way we can actually rename the function. So apart from this, we also have the option to actually modify the signature of the arguments that this function accepts. So I'm going to maybe copy this and come down here and maybe call this return lines. And inside here, what I would like to now do, so apart from just the name, we can also, of course, change the signature of this function. And of course, this cannot, as you can already see from the error that we are getting, this should actually be in quotes, in parentheses rather. So what I can actually do now is assuming, for example, this argument takes, let's say, what if this takes, let's say, a number that is an I32, for example, not 132, but I32. So if this is the case, I also have the option to actually use this and maybe provide a default argument. I can maybe set this to -1, for example, and then within this function, I can now decide what I want to do with this. So when this is not given, num would of course become 1. So that's one other modification we also have the option of doing here. And then here, maybe now I can actually, maybe I change this again to just I32. And here I simply return none, that's to keep it as simple as possible. So that's one thing else we can actually do to the function. So apart from changing the name, we also have the option of playing around with the function signature. And just like you can in Python, you have the option of maybe actually providing an argument or providing none. And we also can do that here. I can maybe again copy this, come down here, create a new function. Maybe I'm gonna get rid of this Pyo3 trait for now, and I can call this return um, either or. And now what I might want to do is maybe to make this argument optional. So I make this option. And now, so I have now, of course, now this function is receiving these arguments this way. And now we also again have the option to actually do something like say num.unwrap. We can actually do an unwrap or and then provide a default, for example. And let's see. And now what I can actually do now is to use the signature. I'll bring it up here. And now I can actually make none to say none. So now I've given the user the option to use this function, either providing this argument or not. So when they don't, of course, this would be none. And in that case, would get back 0 as the default. And when they do, then we'll of course return that value. So that's also one cool way we can develop while keeping Python in mind. So the next thing, of course, regarding these signatures that I would like to show you more or less would be, of course, I think the correct name would be function options. So we've looked at name, we looked at signature. The next thing I would like to show you would be signature, text signature. So this function, we can give it some documentation, and we can say something like returns none if no value is provided. And this, when we look at the text signature of this function, is definitely going to give us something like this. But again, we have the option of actually overwriting this in a very simple way by just coming up here and adding text signature. And now I can actually set this to whatever I want to. I can also set it to none. So what this would mean that is when you look at this, you try to look at this test when this is of course compiled and wrapped and invoked from Python, you would not see this anymore. Now you would see something like this. So now I have the option of actually coming here and putting whatever it is I would want to, that is going to be more descriptive, whichever way I want to have this defined. So this would, again, in my opinion, be very much handy to play around with the test signature of your function declarations. So I would like us to quickly look at raising errors. So to raise an exception, a Py function from a Py function like the ones we've been defining all along, we only need to change the return type t to Py result, so that when the function actually returns an error, it will raise a Python exception. There are already a predefined list that's of possible errors you can return, but of course we still have the option to define our own custom errors by implementing certain threads for those custom errors, and then we should still be fine. So to return an error from a function, I can maybe come down here, define a new function. I'm just gonna copy most of this because I don't want to type everything out. So I can define a function here, and I can say, call it maybe check positive, for example, and maybe it takes an I32, and then it tells us if this is it checks for us if this is positive or not. So for this function to be able to handle error, we should be able to change the function so that it returns a Py result, and that's really mostly what we have to do. And within the function now, we can go ahead and do our checks. So now we can say if something like if x is less than 0. If it's less than 0, then it is really negative. And now we can return our error. And in here, we now need to return a Py value error. So I can say Py value error, I say new error, and now I can add my string. Here I can say s is negative, for example. And other than that, we simply can return our OK here, and it probably does nothing. So that's one way we can have a function return an enum, more or less. That's going to be either an error arm and or an OK arm. And OK arm. But of course, apart from returning like predefined errors that you already have within this within Python, we can of course define our own custom errors and then implement certain threads on those custom errors, and we should still be fine and return them as regular errors that Python would understand. So imagine, let's come down here. Imagine we wanted to define our own custom error. So I'll call this custom error. And imagine we wanted to define our own custom error. I'm going to add the debug threads already. So for these threads, for us to use this as a custom error, of course, we need to first implement the error, the standard error on this custom error. So I can say import std error for custom error. And in this case, we are going to take like the base implementations that we get from this custom error. And now if we hover over this, of course, we still, as you can see, we still need to implement display, and that's also totally fine. So I can come down here and again this implement display. So input display for custom error. And we need to, of course, have our FMT function like this. And I'm just gonna maybe down here, I'm just gonna do a write. Nope. I need the write macro. So in here now, I can of course just pass F and add some custom string. I can say something like some error has occurred, something like this. And now this should be fine. And the last thing, of course, we'll need to implement for this custom error will be the from thread. So now I can come in here and say import std convert and from, and I provide my custom error. And I would like to do this for pi error. And then in here now, I need to, of course, implement from, and that's totally fine. And this is now, of course, where I return that custom error depending on what I want this error to be. Maybe it could be an OS error, it could be whatever the case may be. So if it is an OS error, I have, let's say, pi OS error, OS error like this, and I can say new error. And now I just return my error, say value to string, for example, and now we are good to go. And now we can, right here that we are returning our errors, of course, we can now go ahead and use our custom error and we should still be fine. So that's just one cool way we can have our own custom errors defined, and of course use them. Having when we compile our code and bring this over to Python, we should still have no problem using this within Python. So now we're going to talk about classes. So I'm just going to come down here, and this is where we'll talk about classes. So to define a class, I can simply come down here and of course use my annotation. I have to use the PyClass annotation, this one. And then down here, I simply define my struct. So I can call this class 1 like this. And inside of it, I'm probably just going to add one attribute. I call this ID. So it's going to be of type i32. And this is already my class, a very simple class. And I also have the option of defining a tuple class. I'm just going to call this tuple. I call this tuple class. That's going to be the name. So again, I copy this attribute up here, and then come down here. I define my struct, and I can call this maybe tuple class, and then maybe it takes a string, whatever, doesn't really matter. And that's one simple way I can define my tuple class. And just one thing you could already see is just by adding these singular traits, I get over 170 implementations on this struct. That's crazy in my opinion. So before we continue, maybe I come up here and say a little bit about enums. So these are enums that you can use in Python, like this enum.enum. And to define those again, it's actually pretty straightforward. We still use the Py class trait. So I'm gonna come up here again, define a Py class trait. But within it, I'm gonna pass two arguments. I'm gonna pass equal and equal int. And down here, I will now have, of course, I would add my my debug, my partial equal rather trait, um, partial eq. Do I have that double? I think I do. And of course, I didn't close this one, my bad. And then down here now, I can define my enum, and I can call this sample enum. And then in here, I now define my enums. So again, I can give it whichever name I want to call this, and I can call this maybe first D, second D, whatever, and maybe lastly, I can actually give this a value, and I can call this 30 or whatever, maybe 10. And so that's actually how we can define enums. So in these are actually referred as units, unit variants. So there are enums of unit variants. And of course, other than this, we also have the option of actually defining enums with structs, and of course tuple variants. That's also quite possible. And to do that again, it's also quite easy. So maybe I'll just come down here and say um, units only enums. And down here, I'm going to define a new one. And this, of course, would be our enums with structs and tuple variants. And I'm going to call it um, tuple enum. And again, I add my annotation, Py class. I'm just going to go ahead and give it a name. I'm just maybe call this something like maybe shape. For example, let's see. So in here we can have circle, and this circle could maybe take a radius that's going to be let's say f32. Okay, and then we can, just like this, we can again define rectangle, and this one would take a width that's like maybe f32, and height that is again also f32. And just like this, we can of course define as many tuple variants as we want. And yeah, we can go on and on whichever way we would want. So these are some of the enums, of course, that are possible for us to define in Rust and then have them used from Python. Now going back to our classes, we can come to class 1. So since we already have this class defined using the Py class annotation, to define the methods of this class just exactly like we would in Rust. So I'm just going to do import class 1. And now the only interesting thing is, again, now up here I need to pass another annotation, and this would be the Py methods. And in here now I have the option, of course, of defining the very all the possible whatever I would like, or the possible methods I would like this class to have. But I would also like you to note here that by default it is not possible to create an instance of a custom class from Python code. And it should note that. And to declare a constructor, we would need to define a method and annotate it with the new attribute. So only Python's new methods can be specified. For now, init is not possible, so there is no init trait more or less. So but for us to have a new for us to have like a constructor for this class from Python, it's quite simple. We can come up here, add a new thread, so new, and then down here, come on, down here we can define the function, give it any name we want. I'm still gonna call it new. So I'm gonna give it maybe it's gonna take an ID, which is I32, for example, and it should return self. And then down here, I can now just return class one like this, and I return the ID. So I can actually do it like this. So this is one cool way we can actually add a constructor for this function. Again, remember most of all we defined up here, error handling or whatever, we can also have those functions in here. So a function should not always return an argument. It can also return a result. Like already seen here, it can return an error, can have an error arm and of course an OK arm. That's also quite possible. That's also some of the things I find quite interesting working with this. So I would like to talk to you a little bit about inheritance. I'm trying to be as fast as possible. Again, we can go deeper if anyone is interested. If people indicate interest, I'm just going to come back and do like a much more detailed tutorial on this if you want. And we can even maybe solve like a real life problem, like build an actual project that we can maybe try to use in, say, a Python application. That's also something we can do. So if we want to talk inheritance, what I can do here is quite straightforward. I would have to create a bunch of classes and then try to see how we can take care of inheritance. So in here, I can define a base class. So again, I'm going to annotate this with let's call this Py class. And so, but now I would like to add a special attributes subclass. Okay, and then down here I would like to define my class. I can call this base class, and it's probably maybe just gonna have one thing. I can call this like we did before, maybe ID I32. What happened? Did I just shut down everything? Okay, so we have our base class, and now I would like to import this base class. So again, just like what we did, simply add Py methods, and just like you would in Rust, we'll import our base class. Again, you have the option of doing a new if you want as a constructor. So again, I'm just going to maybe copy this, come down here, and we already have our new class. And of course, I'm going to copy this. Okay, and then we have our new class, and then of course we have the option of adding additional methods. So I can add a new method, and I can call this method, I don't know, method A, for example, and add pass a reference to self. And what should this return for us? Maybe it returns an I32 again, for example, I don't know. So, but I would like to make this optional to handle error. So I wrap this, of course, in Py results, and then I add my I32. And then in here, what do I need to do? I simply say OK, and then self.id, and that's it, we are done. Okay, so we've actually implemented our base class. So now we have the option again of implementing a new class, our sub class. So this is going to more or less inherit from our main class. And to do that is also quite straightforward. Again, I'm going to do exactly what we did here. I'll just copy this, of course, without the comment, come down here, and then I can name this maybe sub class A, something like this. And now, but apart from this, I would now, before this, maybe I do something like this, and then up here I say extends, and I need to say what it's going to extend. So it extends our base class. Okay, and now in here I can have maybe it's going to have its own ID, doesn't really matter, or maybe I give it an ID2, for example. And now you can already imagine what our new function could look like. And again, I'm just going to show you. So in come on. So here I define again our new function. What's happened? Oh, my bad. My bad, of course. I'm gonna copy this one again, come down here, close that up, and of course, this would now be our subclass A. So in here now, I can define my new function. Oh, come on, fn new. So it's not gonna take any argument, but I would like it to return. So now the return type, of course, will now be two actually. So it would return self, and it will also return our base class. This is how it's going to look like. And then in here, of course, we now have the option of maybe returning something like this. I say sub class A. And in here, I pass maybe some instantiation, for example. This is me trying to use the first one. I can say ID2 is equal to, I don't know, 5, whatever, doesn't really matter. And then I, of course, have my base class. So I say base class, and I can just even use a new method to instantiate my class. And I can even maybe, if I want, do it in such a way, of course, that this also takes an argument. So we can have something like this here as well. So now I pass the ID here, and of course pass it the new one as well. And I can even modify this, do whatever it is I want to do to change this, just whatever. So, but the cool thing now is, of course, within this class, we are now able, of course, to extend our base class. And when we use this class, we are now also privy to the methods that are within this base class that we are extending or more or less inheriting. The only thing we need to pay attention is that to get a parent class from within a child, we would need to use pyref instead of just reference to self for methods. Or we can also use pyref mut instead of just immutable reference to self. And I'm going to show you what I mean by that. So imagine that within this class, we also have a function called maybe I also maybe it's pub like we have above, and I call this method B. So this is method, also method A, doesn't really matter. Method A from our class that is of course inheriting our base class. And if within the functions we said that to have access to the, of course, to reference our base class from this child class, that we would not be going, like we would not be using reference to self, rather would of course use pyref. And I can show you that's also quite straightforward. Okay, so in here we're gonna have self, give it any name you want, and then down here, um maybe I can actually annotate it like this. I call this self, but now this would now be from pyref. And within pyref, I provide a lifetime argument, and now I provide self. And this is one way we would now have access to we now have access to the methods that we have in our main class. And now, of course, we can make this quite similar to the one we have above. So it's going to simply return a py result. And this is also going to be like an I32 like we have above there. And now down here, we can now actually use the one that the method from our main class. So we can now say, I can maybe create a super like this, and I say let's super. So this would be self. Now dot, we'll say as super, and this will of course get me a reference of base class, but this reference now will of course be wrapped with pyref, as you can also see over here. And now I have the option of saying something like super dot method A, and I think that's mostly it actually. So that's actually one way we can use the argument from here. But we cannot just go ahead and reference this self. It's not going to work. So again, this what we have here right now is actually similar to something like this. So we have a reference to self, and if we wanted to have a mutable reference, this can now be mute. So we have pyref mute, and that would not become something like this, reference to mutable reference to self, something like this. So that's actually one way of doing it. And if you look here also, that's also what we get. Okay, so I'm going to remove this just for you to know that, that's also possible. Again, we cannot use this as this within our subclass. The child class is inheriting from the parent class is not just going to work. We would have to do it like this. That's really the point I wanted to pass across here, guys. So the last thing I want to talk to you about would be object properties. So with object properties, for simple cases, for example, when where a member variable is just read and written with no side effects, we can actually even declare getters and setters. So this would, of course, if you're of course familiar with OOP, you would not have any issue understanding how this could work. Okay, so what simple example I can actually do is within our subclass A, I'm probably going to come up here and add an annotation. So this is going to come from Pyo3. And what I need from here would be my get and set. And now what I can simply do is to come inside of our implementation for subclass A. And now I can actually add some setters and getters, for example. So I can come here and define a function, say get ID. This ID is going to go take reference to self. Again, I'm accessing attributes belonging to subclass A. Just pay attention. If those attributes are from the parent class that we're inheriting from, again, remember this is the route we have to take. Okay. So at this point, if I want to get the ID, what I can actually do is maybe again return a pi result and again return an I32. And now I have the option of actually saying, okay, self.id, something like this. And now we have access to this. So, but for this to be a getter now, I would of course have to prepend this with getter like this. And again, we can also have something similar for setter. It's quite simple as this. So I can have here setter. I'll come on and then fn, and I say maybe this function should actually be public. So fn, and I say sets id, for example. Now we would need a mutable reference to self because now we would need to modify something. So we now have our value, which should still be, of course, has to match the type we want to change. I32, and now of course our pi results. Again, it's not going to return anything if everything goes as expected. But again, we've already covered errors, so you have now option to define custom errors, return them, and of course, everything should still be fine. So self.id. So ID now will become the value that we provided. And now down here, we simply say okay, and that's it. So that's really one cool way we can modify the properties of our class attributes. So it's really quite straightforward if you ask me. And last but not the least, I would just want to show you this. I'm just going to comment this out because I don't want to define three separate functions just to show you this. So, but we can now, of course, define, let's say, class methods. We can define static methods as well. And those are actually pretty straightforward. They are regular functions just with an annotation. So this, if we want to define a class method, it's pretty straightforward. We need only to provide a class method thread, and of course to create a static method, again quite straightforward. Static method. That's all we need to do to define these two attributes. So that's really what I wanted to show you. If you want to define a class method, you use this. A static method, you use this. So that's really what I wanted to show you guys in this series. Again, like I said before, I really think this is cool. If you're working on projects, say in Python, but you know some Rust and you discover that some aspects of your code are actually slow, especially for example when it has to do with, let's say, some I don't know, maybe some inner really crazy loops or some iterators, you're working with some iterators and generators, or you have some vectorized operations, for example, or you have some custom data structures that you would want to take from Rust and take leverage that, of course, and have and experience the benefits in Python, or you doing some memory management, some complex algorithms, some numerical computations, some file input outputs, like some intensive network IOs, or whatever the case might be, or it can even be some system calls, some syscalls, and you feel maybe you would squeeze out some crazy and you would actually benefit from Rust to maybe improve speed or take away memory leaks and stuff like that. And you would want to have this written in Rust, and then have a wrapper that you can actually invoke this from Python. This is one cool thing I think you would need to explore. This might, of course, be the solution to the problem you're having. Again, like I said, we would keep this brief, and that's just what I've tried to do here. I don't want it to be as crazy long, but of course, like I promised you, if there is really need for me to dive deeper into these topics, and maybe we build something quite interesting together, just let me know. I would squeeze this, of course, into my schedule, and then we'll see how we can go about it. Anyway, guys, that will be all from me. Now, thank you so much for being part of the journey so far. We are still trying as much as we can here to bring you interesting content to make dev and development in general as easy as possible. And so, if anything is not clear to you, feel free to reach out. Otherwise, our sole aim for creating this channel would be defeated. Of course, if you're new, go ahead and subscribe. Turn on the notification bell; would always notify you when we have a new interesting content for you. Anyway, guys, that will be all for now. Until we see each other next time, have a lovely evening and take care.